Being an engineer or technician, our major role in industry is to maintain the system running without fail. If any machine gets shut down, we need to restart it in short time. In today's industries, where production rates and product demand are very high, machines should not get shut down. If it is shut down, then it should be restarted very fast. Now our first problem is that, from where to start finding the problem in the machine, which is very large in size and spread in large area. Actually, we have not to be worried about the largeness of the machine, as largeness is just a mechanical structure. Often, we don't get any problem in structure once machine running trail is checked off. So, we have not to be worried about the largeness of machine, but we have to concentrate on three parts, i.e. input, controller, output. These three parts of machine are the important parts in terms of finding problem. Most of time, machines are shut down because of its input, output issues. We find issues in controllers rarely. Now we go to find problem and inputs, and we face another issue, i.e. large number of inputs. It can be 100 or 1000. You can imagine how difficult is it to find problem among such large number of inputs, and it will take time also to do troubleshooting. The same problem we face among outputs. If we have advanced controller with advanced featured software, we can find problem in 5 to 10 minutes. We shall have a discussion about controller. A controller monitors and controls any machine system. Initially, when industry started, it was all manual operation. Manual means a man was the controller. It was a man, operator, who used to monitor the system, and she was taking decision of operation too. This manual system was not accurate and was so time-taking. System. Very first automatic controller came in industry was relay logic controller. It was a large complicated electronic circuit, full of many small and big devices. The logic was designed through wires with the help of electrical and electronic devices such as relay, contactor, hardware timer, counter, diode resistor, capacitor, etc. It was complicated but automatic system. This relay logic can be seen in some old industries. Railways also use relay logic control. Now it is being replaced with advanced controller. It was a good controller, but obviously it has some limitations. Once it was shut down, it was so difficult to find problem in that large complicated circuit, as it was no any monitoring system that time. Another issue was, once the circuit was ready for one application, it was very difficult to modify that circuit for another application. In fact, small modification was also difficult. You can see one example of relay logic control in college machine lab. The motor is on and off by to push buttons, green and red colored generally. Push button has spring system inside it. When push button is pressed, it conducts and supply reaches to motor. When push button is released, due to spring, push button gets off and signal does not pass through it, but motor still runs. How? There is no any microcontroller that you can see. It is continuously on because of relay logic. Motor is latched by a relay. Another very famous controller was microcontroller. This is a very famous controller, especially in academics. It is a very good controller as it is very compact in size, very cheap in cost, and the best part programmable. If you are able to program your controller, you can make modification in your existing system as per requirement, but still it is not used in industries to control machines, and this is the reality. Microcontroller is a very good controller, but it has some limitations, because of which it is not the main controller in manufacturing industries. The main controller to control machines in industry is PLC, Programmable Logic Controller. It was originated in 1968 in automotive industry in USA, on the proposal request of Hydramatic General Motors, for replacement of relay logic control system. This proposal was written by Edward R. Clark. The selected proposal came from Bedford Associates. First PLC 084 was built in 1969. It was their 84th project, so named it 084. Bedford started a company dedicated to developing, manufacturing, selling and servicing the new product Modicon modular digital controller. Dick Morley, one of the people who worked on the project, is considered father of PLC. This brand Modicon was sold to Gould Electronics in 1977 and later to Schneider Electric, the current owner. The first model 084 is still with Schneider, which was presented by GM when the unit was retired. After nearly 20 years of uninterrupted service, Modicon used 84 moniker at the end of its product range until the 984 made its appearance. In a parallel development, ODO Joseph Struger is sometimes known as father of PLC. He involved in the invention of Allen Bradley PLC. During 1958 to 1960, he invented the PLC acronym. Allen Bradley is now owned by Rockwell Automation. Struger played a leadership role in developing THIX 11313 PLC programming language standards. In general, PLC is an electronic digital device which takes input and generates output as per logic developed. It is a digital device. Only digital input. Outputs are directly connected to its I/O terminals. Analog I/Os are not directly connected to PLC directly. ADC analog to digital converter and DAC digital to analog converter are always to connect analog I/Os with PLC. Some PLCs provide few analog I/O terminals on its main unit. In that case, ADC, DAC are placed inside main module. In industry, generally ADC, DAC is used separately because the number of analog ITOs will be more. PLC is used to control machines in any kind of manufacturing industry, such as automobile industries, cement plants, power plants, oil and gas plants, food processing industries, chemical plants, pharmaceutical industries, printing and packaging industries, etc. Before we discuss the limitation of microcontroller, let me clarify that advanced controllers also work on the working principle of microcontroller. Advanced features of advanced controller were not added to microcontroller, but a new controller was introduced to sell at higher cost. Let us understand the limitation of microcontroller, because of which it is not used in today's industries. In microcontroller programming languages, its programming language is based on C language. It is not that easy language to be learned by all, while in PLC, it has 6 programming languages. User can select language as per comfort. Ladder diagram is Theseus language. It can be understood very easily by maximum learner. Ladder diagram is preferred by industries because a troubleshooting is very easy in it. Download, upload timing in microcontroller takes more time to send program to controller, while in PLC, it takes fraction of second or a few seconds to send program to controller. In terms of program receive option in microcontroller, it has no program receive option. If you don't have program backup file, then you can track of a program from controller. You will have to rewrite that logic organ without receiving existing program of controller. Troubleshooting is also very difficult, as we won't be able to understand the machine operation logic, while in PLC, existing program of PLC can be received very easily even in running condition of machine. If your program backup file is lost from your computer, then you can receive program from PLC. In terms of monitor, online mode in microcontroller, its software has no good monitor mode to check running status of machine. Its monitor mode is not that much helpful in troubleshooting machine. It has good monitor mode in its software, which helps a lot in troubleshooting machines. If any problem occurs in machine, we follow few steps to reach to the exact issue. Take laptop, computer, which have that PLC software installed in. Connect PLC communication, cables one end to PLC and another to laptop, computer. Open the software, set communication and click receive, upload, read, PLC to PC option. Given in that software, the existing program will be received in that PLC software. Now go to Monitor, Online Mode. You will be able to monitor the running present status of addresses you set in that program. You can search out outputs which is not working as per sequence. You can easily monitor that why the main supply does not reach to that output dot. You will easily reach the problem within minutes. Without program receive and monitor mode, it's very difficult to troubleshoot any complicated system. Online edit in microcontroller. Online option is latest and the best option in automation. Software many times, it is not possible to stop machines to avoid production loss. But some modifications are required for efficiency. If you modify existing program, then you need to rewrite it to PLC and it will stop machine. Microcontroller has no online edit option. Now PLC software has option to rewrite modified ladder without stopping machine. Using online edit feature of software handling in microcontroller, it is not that much robust. It has less ITOS and registers available dots. It is not that much life compared to PLC. While handling in PLC is manufactured to work in extreme conditions in industry, it has large number of IOS and registers handling capacity. Thefus PLC 084 was retired after 20 years of uninterrupted service. It too, because that unit was retired. PLC can work long life. Usages in microcontroller. Generally, it is used for small applications or mostly in home appliances, where it is replaced with new one when out of order. While usages in PLC is used to control small to big machines in industries with a large number of logic sequence. And that concludes our introduction to controllers, covering the history of PLCs and the differences between PLCs and microcontrollers. Please ensure to subscribe to my YouTube channel for regular updates. Your support is greatly appreciated. Please don't forget to like and share this video if you enjoyed it.